All right, practice test number 11. Let's go through what we didn't, well, let's just go through it real quick. The first four problems are from what we did on Monday, which are geometric sequences, and that's when they're multiplying the same number every time. R is a ratio. Remember, you find R by putting the second over the first. With explicit form, the formulas will be, I'll put them on the board today. They'll be on your the board tomorrow for you. And it's basically first term times R to the n minus 1 power. That's explicit, and I got those from right there. Recursive form, remember you have to have fn minus 1, which means the previous term. You do 1/10 times the previous term to get the next term. And don't forget to tell what f1 is, 1,000, after you do that. Number 2, they give you the explicit form here and want you to fill out their table. So you just plug in the first one, plug in 0 where the x is, work it out, you got 1/2. Plug in 1 there, you got 1. Plug in 2, you get 2. And then you can kind of see a pattern, like it's doubling out down here. So it's going to keep on. Plot your points: 0, 1/2, 1, 2, 2, 3, 2, 2, 4, 2, 4. I can't read it. 4, 8, and it should look like an exponential, like we did later in the week. Number 3, they gave you recursive this time, but they told you what the first one was 0.5. Then they tell you they're multiplying each term by 2, so do 2 times 0.5, 2 times 1, 2 times 2, 2 times 4, and then plot them on there. That last one doesn't quite fit, but that's okay. On number 4, the best way to do these, after you read it here and it says, they have 128 players, each match 2 players play and only 1 moves on. Start writing it out. Like with 0, before any matches are played, you have 128 players. After the first match is played, you have 64. The second round, you have 32 left. And just kind of start that out. Then you can write your formulas here like we did on number 1. The explicit, first term times r to the n minus 1, and recursive. Now, when you go to solve the problem down here, like how many matches does a winner play, you need to use the explicit. After the championship round, there's only one person left. 64 was the first term. R is 1/2, n minus 1. So what I did really, I just divided by 64. Then I took my calculator to figure out how many times, 2 to what power 64. The answer is 6, 2 to the 6th power. But because it was n minus 1, it has to be 7. Okay, number 5 through 8 is what we did on Tuesday. We started adding up the series, the geometric series, and you got the formula there, the first term times 1 minus r to the n over 1 minus r. One of the biggest challenges is making sure you get it in your calculator correctly. Use all the parentheses that you need to get there, and don't forget your little 7. Don't forget that 7 just goes for the negative 2, not for the whole top. Be careful when you punch that in. Number 6, same deal. Make sure to find r. R is the second one over the first one. And punch it in your calculator successfully again, and make sure you get 110 over 27. I think I messed that one up today during class. Number 7, find your r, and you know what the first term is. What you do not know is what n is. So what you have to do on 7 and 8 is you have to go back, and I'll see if I can make this bigger right here. Yeah, you have to go back to the original formula, this one, and to find your n. So I took the last term, fn means last term, took the first term, r I figured out was negative 3 to the n minus 1 power, divided by negative 3, and now I'm doing the calculator thing again, trying to figure out negative 3 to what power is 59,401, and it was actually the 12th power, so that means it was the 10th power, so that means n has to be 11, because 11 minus 1 is 10. Then just put the 11 right here, and you're good to go. On number 8, it's the same exact thing. I set up what I could. What I knew was the first term. I knew what r was. What I did not know was what n was. So I came over here and did the same thing. I took the last term equals the first term, r n minus 1. I divided by 12. I got that. Then I had to figure out 3 to what power 729. 3 to the 6th power is, which means n is 7. So I took the 7 and put it where it goes, punched it all in, and got my answer. Okay, 9 and 10, well, 9 through 12 really. These are exponential growth. That's what we did on Wednesday. And it's growth because the number inside the parentheses is bigger than 1. That's bigger than 1, that's bigger than 1, that's bigger than 1, that's bigger than 1. We're not going to worry about the first one. That's just the parent function. Don't forget to do this part right here. Don't forget it says describe. Anytime it says describe, you got to tell what kind of shifts or reflections or anything like that. Because it was negative, it reflected across the x. 3 means there's a vertical stretch by 3. So I went ahead and drew it. I went to drew my asymptote. The 3, I had to go down the negative 3. Remember, because it's growth, you have to go 1 to the right to get your next point. If you plug in 1 right there, it gives you negative 6. So I went to 1, negative 6, drew my graph. Don't forget your domain and range. The y-intercept, you just plug a 0 in for your x, and you're good to go. Number 10, You got your y-axis, got your asymptote right there. You usually go up 1. This time you go up 1, left 2. And because it's still growth, you go over 1 to find your next point, found it, plug a 0 in to get your y-intercept. 11 had a -2, so you shift your asymptote down 2. And to get your first point, you're going to go, instead of going up 1, you're going to go up 2. And also there's a shift there. Let me go bigger here. You shift -1, so I went up 2. Sorry. Went up 2, left 1 to get my first point. Went over 1 to the right, which puts me at 0. If I plug in 0 up here, it gives me 2 times 3, which is 6, minus 2 is 4, so 0, 4, until your domain and range. And number 12, same deal, asymptote is at 2, so do that right at 2. My first point is going to be down 3 because of the -3 in the front, so it puts it right there. And also right 1 because of the shift there, so we'll go over 1, down 3. To get my other point, go 1 to the right, plug in 1. If you plug in 1, that just becomes 1, so it gives you -3. Plug in 2, which gives you -3 times 2, which is -6, plus 2, which is -4. So that's my second point. Don't forget your domain and range. 11 and 12, more of the same. Actually, we just did those. Just did 11 and 12, so we won't do this again. Don't know why I took a picture of that again. 13, 14. 13, 14, it changes because now we're talking about exponential decay, because that's a fraction, that's a fraction. You don't have to graph 13 and 14, you just got to tell the domain and range and what the transformations are. This one has stretched by 4 vertically, has a shift right 3 and up 2, and domain is always the same. I think you're going to get domain right tomorrow just fine. The range, because it's going up, because it's positive, it's above the asymptote, and the asymptote's at 2, you would say 2 to infinity. 14, same deal, shifts up 3, which means your asymptote's at 3. Domain's the same. The range, because it's still positive, it's above the asymptote, so it goes from 3 to infinity. 15, what's happening here? There we go. 15, it just says you graph it until domain and range, so because the 1/3 is going to go down, it's decay, so draw your asymptote up 2. Usually I'd go up 1 right there, but this time I'm going to go up 4 and right 3 because of the shift 3. So there's my first point. And when it's decay, when it's a fraction, instead of going 1 to the right, we go 1 left. When we go 1 left, that makes our exponent -1 every time, which changes that, it flips that, makes it 3. So you do 4 times 3, which is 12, plus 2 is 14. So when I go back 1, I'm going all the way up to 14. I kind of estimated there. Draw your graph to your domain and range. 16, you got to come up with the equation this time. So first of all, my asymptote's at 3, so it's got to be a plus 3 out here. My first point's 2 below it. That's where the -2 for vertical stretch came from. It's also supposed to be on the y-axis. It's actually shifted left 4, so put a plus 4. So all I don't know is what my b is. And to figure out what b, to figure out what b is, take the other point down here. You know, the graph goes through it because it works, so plug it in the equation. Put the -5 where the x was. I did that. -5 plus 4 is -1. That's why I put a -1 there. The y coordinate is -3, so I put the -3 there. Then I did this. I just solved it. I moved that 3 over, got -6. Divided by -2, I got 3, but I still had that b -1. Remember, negative exponent means you flip or do reciprocal. So I did reciprocal of 3, which is 1/3. There's my b, so I just plugged it right there, and that's what I get. And then don't forget also to your domain and range. 17, you can't do anything on 17 unless you make the bases the same. So I had to make that become a 3. 81 is really 3 to the 4th power. And the cube root, remember, bottom is the root, top is the power. So I wrote it with an exponent and put 1/3 because the bottom is the root. This one had 3, had bottom is the root, cube root, 2 is the power, top is the power. Now, with those two exponents written like that, when you have a power raised to another power, you multiply your exponents and got 4/3. Still have this 3 to the 2/3. They're multiplied together. When you multiply, you actually add the exponents, which gave me 6/3, which is 2. 3 squared is 9. 18, an equation with a radical in it. You've got to square both sides. If you square the left-hand side, the radical just goes away. That's simple enough. This side, you got to be really careful. Don't forget what you're supposed to do. You square the first term. You multiply the 2 together and double it. Then you square the 1. Then you start moving stuff over. If I move the x over, the 2x becomes 1x. If I move the 3 over, it becomes -3. So 1 minus 3 is -2. I factored that. X plus 2x minus 1, which gave me these two answers, -2 and +1. Anytime you have an equation with a radical in it, you must check your answers for extraneous answers. -2 on this side right here alone made that side negative, and because a radical cannot equal a negative number, -2 cannot work. Try the 1. If I plug 1 in here, 1 plus 1 is 2. That's pretty good, so plug it over here and make sure. 1 plus 3 is 4, the square root of 4 is 2, so both sides equal 2, so 1 is a good answer. All right, 19 and 20. If you do square root graphs, you get half of a parabola. So 19, usually you start at 0, 0, but because I had a -1, you start down 1 right here. These graphs are in halves, so be careful. And to get your next point, you go over 1, down 1, so draw your half a parabola that way. Your domain is x is greater than 0, because that point is going to be where your domain and range come from. It's starting at 0 on the x and touches a 0. It's starting at -1 on the y and is going down, so I'll put less than. If you look at 20 right here, it's like I forgot to do 20, so I'll do that live for you. Thought I had everything done already. I'm going to shift left 3 and down 2, which is going to put me, about right here. And because I have a 1/3 in the inside, it's a horizontal stretch by the reciprocal. So I would say, instead of going over 1, up 1, I'm going to go over 3, up 1, which should put me right there. So connect the dots, la, la, la. And my domain, remember your domain and range come from your beginning point. So I'm going to put x, x is greater than or equal to -3. And the range, I'm going to say the y, whereas y, this time it's going up, is greater than or equal to, oops, I put the wrong way, greater than or equal to -2. That's your domain and range. All right, 21, adding fractions together. Don't make this one very difficult. Find your LCD first, which is both of those. 2 times 7 is 14. Bring down the x, bring down the y cubed. Then just ask yourself, same thing, what does this need to look like that? Well, it needs a 2 and a y cubed. So you do 2y cubed times the top, and that gives you 30y to the 4th. Same thing here. What does this need to become that? It needs a 7x. So you do 7x times the top, and you get 21x squared. 22 is division, which means it's really multiplication after you flip it. But what you need to do first is factor everything. So on this one, I took a 3 out. Then I can still factor some more, so I wrote it like that. On the bottom, I need 2 factors of 10 that give me -3, so I put a minus 5, a plus 2. This one I flipped, and I put, this is difference of squares, so I did a plus 2, a minus 2. This one, which is now on the bottom, I took out a 12, which gives me a squared minus 1. But you can factor a squared minus 1 more because it's a difference of squares. Then I started canceling stuff. A plus 1's canceled, a plus 2's canceled, 3 goes into 12 4 times, and then your answer is just whatever's left, and that's what was left, so that's the answer. 23, 24, you're going to need your calculator for these. Punch that in. You can make a list if you want, that's fine. I went ahead and just punched in the calculator, and I noticed it crossed the x-axis at -4, so I took the -4 to make sure. Sure enough, I got 0. Once I got 3 numbers down here, I wrote my 3 numbers up there, factored them. It factored great, x minus 5, x plus 3. So my answers, don't forget, you should have 3 answers because it was 3rd degree, 5, -3, -4. To be honest, I actually saw it cross all 3 places, and you can choose any of those you want to start with. 24, same deal. Punch it in. It crossed the x-intercept at 1. Tried it. Sure enough, I got 0. I took the 3 numbers I had left. It factored again really nicely. 5, 3, and 1. And if you look at the graph, you can see the 5 and the 3 on there. But make sure you write all 3 answers. 25 just says factor. I've already paid real close attention to this. Like this one, this one's on the test. All right, take out an x first. Take out an x, it leaves this. So I'm looking for factors of 12 that would give me a +1, which would be +4, -3. Make sure you write your x with your answer, and that's it. 26 is the cube again. So you go small, big, cube root, square the first one, multiply together, change the sign, square the second one. So that's what I did. Cube root, square the first, multiply together, change the sign, square the second one. 27 is just a circle. They give you the center. Remember, whenever you put something in parentheses, it's the opposite. So I put x plus 5 and y minus 3. I did r squared. Radius squared is 25. Last slide. So we just did the circle. I don't know why I took pictures of it again. 28 says to graph this thing. Count how many x's there are. This time there are 4 altogether because that's squared, which means it's even, which means the ends either both go up or both go down. Put your zeros up there. That would be a 0. That's going to be 1. That's going to be 4. Now, because that's squared, Remember, when a factor is squared, the graph just touches at the x-axis right there, doesn't pass all the way through. So when I drew my graph, because it was even and positive, both ends are going up, I came down, touched it, the 0, went back up, through the 1 because it was odd, through the 4 because it was odd, and that's it. That's all you got to do. 29, it's a parabola. Get your y's together, move the 12x and the 64 over like I did here. Leave your space to complete the square. Half of 4 is 2, 2 squared is 4, add that to both sides. So when I simplify this side, it gives me 12x minus 60. Over here, you can go ahead and write the parentheses. Remember, the half is what goes inside right there. Factor out the 12, that's going to be your 4p. 12x minus 5 equals y minus 2 squared. And now you can graph. The vertex is going to be careful when you write the vertex here. The vertex is 5, 2. Notice the 5 is with the x. Even though it's on the right-hand side, the 5 is with the x. So what I did is I went to the graph and went 5, 2. That's my 4p. 4p is 12, which means p is 3. Because my 4p is with my x, the parabola goes like the x-axis does, goes sideways, and because it's positive, it goes right. So the focus is 3 inside, the directrix is 3 outside. There's your parabola. Hope that helped. Probably a little bit longer than usual, but the test is pretty long. So study hard. I'll see you tomorrow, and hopefully you'll do great. See ya.